I'm going to talk today about doing a batch load using the Lambda into dynamodb. We used it for our lifetime check-ins, which was about 217 million items that we need to get into the dynamodb table. The structure of that table was plural strings, and then our partition key is the member ID, and then we had a primary source key, which is the local timestamp of that check-in. And then the source of this query came from a view from Redshift. So the architecture that is set up to do this was, so the original source of the records came from Amazon Redshift view. We took that view and we broke it up into little files that we stored into S3. And then we took, and then we created queues, which would give instructions to the Lambda function to pull those files in the S3 and then to send them to dynamodb. So for the first step, user, so that was me, I ran that query on Redshift and then dumped the files into the simple server. So simply, I ran an unload statement on that query and I sent it to the S3 location. And then I also, if you see on the very bottom, there's a max file size of 5 megs. That kept it so that each file contained about 250,000 items, which we were going to send into dynamodb, and it created around 832 files for this project. So then the next step was to do the messages. So we connected to, we need to connect to S3 and SQS, and the way we did was the files that got created, so the 832 files that were created, we pulled into the response, and then I created 40 buckets, which were going to, each bucket would be its own queue. Then I went through the response to pull in the key and just to load it in so it was evenly spread out between the buckets. And then I simply sent the message to the queue, which would trigger the Lambda function. So once the queue got sent, once the message got sent to the queue, the Lambda function triggered. And then once the Lambda function triggered, it went through these steps. So it would take the message body, which would be a sample of it would be the file 1 extension on S3, then the file 2, file 3, and it kept on going, and each one was either 20 or 21 files. We would download the file so it would pop off the first record on that message body, and it would go down to S3, download the file, and then I would use the batch writer function that AWS provides, unzip the file, and then I did put in some timing so you can see how fast each 10,000 cycles were for each Lambda function. And then you simply write the items into a dictionary, and then you put that item into the batch. And then it would do only one file, and then it would check to see if the message body had any more remaining files remaining, and if it did, it would resend it to the queue, which would restart up the process. And the reason why we did it like that is because there's a hard limit on dynamodb of 40,000 writes. And so we didn't want to just throw each file out there because we would just get throttles, and it would we'd get a whole bunch of dead letter queues, because what would happen is it wouldn't finish in time because it would try to process all the files at once. So each file wouldn't be getting 1,000 writes per second. It would be doing closer to 50 writes and wouldn't finish in the 15-minute time limit that you get with Lambda. This way, we make sure that there's only 40 Lambda instances going at once for 40 files at once. And then that gives us the 40,000 writes per second that we want to achieve. So now the cost. So with that, we have the Lambda setting at a gig, and then the current price right now for that is 0.0001667 a second. And then I sort of brought it, and then the dynamodb table is actually the more expensive part. So the write capacity units to get 40,000 was at 0.072 a second. So to do 1 hour at 40,000 writes per second is 144 million, and it would cost $2.40 on Lambda and $25.92 for a total cost of $28.32 of just moving the data, not storing it. So DynamoDB, it's like the first like 25 gigs are free. And then, but if you break it out, you can see how you could easily get up to like 1 billion records. So it would take about 7 hours, but it would only cost a little under $200 to load 1 billion records into the table. And and then another thing is like the 2 tables. So this is to 1 table. You're allowed to do 2 tables. So if you actually wanted to get 80,000 writes a second, but to 2 separate tables, you would actually be able to do that, just separating it out pretty easily. But any questions?
Michael, were you sharing your screen?
Yeah. It says, stop sharing, and I'm like, do you not see it? I'll send you the slides.
Okay.
Who's that, Anita?
Yeah.
Yeah.
So I have some questions.
Yeah.
So what's the, why did you use DynamoDB? Like what is, like, why is it going to DynamoDB?
So we have a milestone project that we're going to be using a DynamoDB table. And we have to put in all our previous check-ins that weren't currently not in there. And they're from the life database. So it was already in DynamoDB, so the project was to add it to that table.
But why use Dynamo over like a P-SQL instance or some kind of RDS instance or something else? Like why did you?
To store the historical check-ins?
Yeah.
Probably for price. It's pretty cheap, and all we're doing is we're just loading in the member ID and the check-in time into that. So it pretty works well with the NoSQL database. It's not very hard to set up, and it's relatively cheap, especially on data storage wise.
But we could have put that S on S3 though, right?
You could.
And then created like a glue table on the top of it to kind of be accessible to all the players.
You could do that, but the thing is, this check-in table is read a lot, right? So we constantly write to it, and then we're going to do some reads off of it based on the last check-in. So you don't want to have to just do that off the S3, especially cost-wise, because once we do this load, we drop down the writes, and then the table, it's like, I think it's our monthly bill is like $46 or something like that for the bill.
So you have just 2 columns here.
No, so there's 6 columns, I believe. So there's going to be the member ID, the local check-in, the UTC check-in, whether the check-in was good or not, and the facility.
Yeah, because so there are just 2 columns of libraries.
Did you drop the one field which I added, the unique identifier one?
Yeah, I didn't need to load that.
And that doesn't have any significance from usage point of view.
And then the Dynamo table doesn't really have it, so yeah, there would be no reason. The reason why we did this is because we need to, on the milestone checks, we need to see how many check-ins a member has. So we need to just pull it in. So we're going to aggregate based on their since date to the current date of the last check-in to do a count of how many check-ins they have.
In real time too. So we're already using this, I think, to power a lot of the check-in stuff within the app.
Yeah.
And so so the reason why we loaded the historical is just because we needed the number per members. Otherwise, we wouldn't have needed to do that. But so basically, like as somebody checks in, we'll query all of their check-ins. Well, there's a little bit more logic on top of it, but that's like the reason why we're going Dynamo over like SQL or something like that. Is because it already exists, so we can reuse it.
But the
So
calculation.
where's the calculation, where's it going?
The calculation will just be the total good check, or not good even, just like the total. There's a little bit of logic on top of it based on the milestone stuff, but it will be basically just as you check in, give us the number of check-ins.
We already have that in F checking, by the way. All those matrices are already calculated, and so this is the one feed which I gave to Michael was the raw feed, right? The bonus preferable, we can do it whatever you want. But the one matrix you're talking about, the number of check-in per member is already calculated on a daily basis, even on like a.
But we need it real time
Yeah,
as they
so-
check in.
Yeah.
So an F check-in takes like 5 minutes to load. So Redshift wouldn't even ever make sense. So that like 2 options were like just build something completely new or reuse this.
In the graph, why do you need to unload the S3 and trigger Lambda? Can you just from Redshift and trigger Lambda to do
So there's no trigger on Redshift to Lambda, and the reason why I would do the files, like the individual files, is mainly to work with queues, because if something were to go wrong, I could get a dead letter queue and I could reprocess the file pretty easily.
So in order to, that's the mandatory requirement, like in order to get to dynamodb through Lambda function, you have to process through the queues.
No, you don't. You could go Lambda directly into DynamoDB. I just prefer to use queues just for error handling, and yeah, it's very easy like to redirect and stuff like that. So if it got redirected to the general like queue, I could just resend it back to the queue if I need to fix it or something else.
So when we talk about the real time, it has to be stat view on top of Redshift, get the S3 file, move from S3 to Lambda, right?
Yeah.
So how much time takes that?
Oh, for this process?
Uh-huh.
So the process to unload from Redshift view
Are you
to
saying going
S3.
forward when we do real-time calculations, or?
Yeah, because I'm trying to understand, it's like, what, are we having now just historical data there?
Where it's gonna be updated directly from the checking queue, it's not gonna go through Redshift.
Yeah, so those two pieces, the historical was, this is what we're
Yeah,
talking
this
about,
is-
historical piece.
But it's one
One time,
time.
done.
One time.
And after that, there'll be a real-time process which will directly go through checking SQ, also SQs.
Yeah, and then there'll be a true up process too. So, well, the true up process already exists where once a day we'll true up the Dynamo table with the F check-in table to make sure nothing got wrong. So it'll be a true up. So we'll have Redshift and a Dynamo table will match at once for that day. And then the member since date will get trued up as well when we do that. But yeah, that's going to be the milestones. Well, that's handled on the DynamoDB side. Redshift's not really for this, other than this one-time load.
Cool.
I have one question about the Lambda functions. How is the deployment for Lambda functions? Because I mean, like, you put them in the repo and then you just copy them over to
So for this one, we don't have really, well, we have a repo, like we save it to the repo, but we don't deploy it. So this one, luckily, I didn't have to zip the file, I could just do it right in the Lambda IDE that they have. And yeah, so you just load it and then you save it, and then it'll actually save all the versions for you, like on the AWS service, the Lambda.
so the version control is over there, is that right?
Yeah.
Did you push all this code to repo as well, or?
So a lot of the like creating the messages and stuff like that.
Yeah.
Well, no, that's generally on my local machine, but I could give you that.
Okay. Yeah, that'll be helpful for all the players to kind of, they have to refer to that.
Yeah.
That'll be nice.
How easy was it to get permissions for everything?
So you have to get the roles corrected. Lambda's sort of annoying with that. So yeah, you have to get the right policies to get everything set up, because the Lambda was reading from S3, well, it was downloading from S3 bucket. It was reading the SQ, was sending a message to the SQ, and then it was writing to the DynamoDB table. So yeah, you have to get the policies.
So Lambda create its policy by itself, or you need to create policy specific for?
You have to create the policy specific. So yeah, the policy statement would be, like for this, we would have records to that table, specific Dynamo table, and then I'll have read and send messages to the specific queues.
Cool. Thanks.